Hello everyone. On this video we will be covering exponential and logarithmic functions. Okay, now the definition of an exponential function with a base that we'll call b is defined by the equation f of x equals b to the power of x, or b to the power of x equals y, or y equals b to the power of x, where two things have to be followed. B has to be greater than 0 and b cannot equal 1. Okay, now here if you have f of x equals 2 to the power of x, your base is equal to 2. Here if you have g of x is equal to 1 over 3 to the power of x, then the base is equal to 1/3. Here you have f of x equals -4 to the power of x. Your base cannot equal -4, because remember, your base has to be greater than 0. And you have f of x equals 1 to the power of x. Remember, your base cannot equal 1, because really 1 to the power of anything is just 1. 1 to the 1,000,000th power is just 1 times 1 times 1 times 1, all the way up to 1,000,000. Okay, so there's no point in having an exponential function if it's just a straight line, or f of x equals 1. Okay, so this is kind of an quick introduction. Okay, now we're going to go into the problem solving part of it. So if you're still writing this, please feel free to press pause. But we're going to go ahead and go to our first couple of examples. Let me bring that down a little. There we go. Okay, so now to solve our equations, our exponential equations, you want to remember that if b is greater than 0, your base is greater than 0, and it does not equal 1, then you can't assume that b to the power of x equals b to the power of y. If you have an equation that looks like this, is equivalent to saying that x is equal to y. So in other words, if your bases are the same, then your x would have to equal your y for those to be true. Okay, so I'll show you what I mean by that. So let's say, for example, if we are solving for x, 6 to the power of x equals 36. And I'm sure a few of you can do this in your head, but we're going more over the process than anything. Okay. Now the one thing you want to do is you want to notice that 36 is equal to 6 squared. Okay, so our 6 to the power of x equals 36 becomes 6 to the power of x equals 6 squared. Okay, so as long as your bases are the same, this exponent has to be equal to this exponent for it to be true. So we see here that x would have to equal 2. Okay, so let's try one where looking at it, the answer won't jump out at you. So let's say, for example, if we wanted to solve for x, let's say 64 to the power of x equals 16. Alright, so this one's a little bit different. The answer couldn't really jump out at you like it would up here. Okay, now there are two things you want to notice here. If you notice, your bases aren't the same. So item you want to notice, number one, is 64 is equal to 4 to the third power. 4 times 4 times 4 is 64. And the second thing you want to notice is that 16 is equal to 4 to the second power. 4 squared. Alright, now noticing those two things, our 64 to the power of x equals 16 becomes, remember 64 is 4 to the third power. So you have 4 to the third power to the power of x equals 16, which is 4 squared. Okay, so now we kind of go back to our rules of exponents. Remember your rules of exponents, a to the power of m and that raised to the power of n is equal to a to the m times n. So we're just going to multiply our 3 and our x. So you have 4 to the power of 3x equals 4 squared. Okay, so we were able to maneuver this to have matching bases. So once our bases match, we know the only way this can be true is if those two are equal. So you have 3x equals 2. So if we divide both sides by 3, we have x to the, x equals 2/3. I'm going 2/3 power. X equals 2/3. Okay. Alright, so if you're still writing, please feel free to press pause. But we're going to go ahead and move on to our next example. Alright, so let me go ahead and bring this down a little. Okay, so let's say, for example, we wanted to solve, clean that off a little, 9 to the 2x plus 1 power equals 81. Okay, so hopefully you're starting to see the pattern. Okay, since our bases aren't matching here, the one thing you want to notice is that 81 is equal to 9 squared. Okay, so 9 to the 2x plus 1 power equals 81 becomes 9 to the 2x plus 1 power equals 9 squared. Okay, so we can see here our bases are the same. So when our bases are the same, this can only be equal if those two are equal. So that means that 2x plus 1 has to equal 2. Okay, so we go ahead and solve for x. Subtract 1 from both sides. So that means 2x, and those two will cancel out. We equal 1. So we go ahead and divide both sides by 2. That means x would have to equal 1/2. Okay, so the key to all of this is being able to get your values and know if it's a value squared or a different value to the third power, somehow changing it to match the bases. That's the key to solving these. Alright, so let's move on to our definition of logarithms. And we have a little bit of room underneath here, so we can go ahead and write it down here. Definition of a logarithm. Okay, so let's say for all positive numbers, and we'll call those positive numbers B, where B does not equal 1 and X is positive. That's going to be important to remember later on. Then Y equals log base B of X. Remember that B is just your base. Is equivalent to B to the power of Y equals X. Okay, so these two mean exactly the same thing. Okay, so let's use this definition to convert some equations from logarithms to exponential form. Alright, so if you're still writing, feel free to press pause. But we're going to go ahead and move on to our first group of examples. Alright, so let's say, for example, we want to convert from logarithms to exponential form. Okay, so we're actually going to do a few of these. So go ahead and create your little table here. So we have our logarithmic equations. So let's say 1, 2, 3, 4. And we want to convert them to exponential form. Alright, so if we are giving log base 2 of 8 equals 3, and log base 3 of 81 equals 4, log base 4 of 4 equals 1, and log base 5 of 1 over 125 equals negative 3. Okay, now sometimes you will have it to where they won't give you a parentheses around here. They'll just have log base 5 of 1 over 125 with no parentheses. Same thing. Okay, I just happened to put the parentheses on mine, but a lot of times you might not see parentheses. They just automatically assume you know that the little small 4 down here would be your base, and the big number next to it would be your value, your x value. Okay. Now remember, we know that log base b of x equals y is the same thing as b to the power of y equals x. Okay. So first, as you can see, we're doing quite a few of them, so they're pretty quick. Here, we have log base b, so we know our base is 2. So converting log base 2 of 8 equals 3, our base is 2. Our y value is 3. And our x value is 8. Okay, 2 to the power of 3 equals 8. Okay, so whenever you're converting, just go right to your base first. then your answer, and that's your x value. That's what it's going to equal. Okay, so log base 3 of 81 equals 4. That's 3 to the power of 4 equals 81. Okay, so I want you to try these two. Just do the exact same thing. Remember here, 2 to the power of 3 equals 8. 3 to the power of 4 equals 81. You do the same thing with those two. Okay, so go ahead and press, well, really shouldn't have pressed pause. You should be able to do this pretty quickly if you spotted the pattern. Alright, so I'm assuming you've filled those two in. So let's go ahead and fill those out. So here we have 3 to the power of 4 equals 81. Do the same thing here. 4 to the power of 1 equals 4. Okay, same thing here. 5 to the power of negative 3 equals 1 over 125. And that's it. Okay, so that's how you convert logarithmic equations to exponential form. Okay. Now we're going to do it the other way. We're going to convert exponential equations to logarithmic form. Alright, so go ahead and slide that up. So if we convert from exponential form to logarithmic form. Alright, we're going to do the exact same thing we did up there. Okay, so if this is our exponential form, we're going to convert each one of those to logarithmic form. Okay. Now we're going to use the exact same rule here. We're just going to flip it around. Okay, so if we have 1, and we'll put 1 here and put 1 there. Okay, so remember, our exponential form is b to the power of y equals x, and our logarithmic form, which is equivalent, is log base b of x equals y. Okay, so for our first one, we have 8 to the power of 0 equals 1. And let's give it 6 to the 1/3 power equals the cube root of 6. And 6 to the negative 2 power equals 1 over 36. And we're going to convert all three of those exponential equations to logarithmic form. Okay, so the first one, you have b to the power of y equals x. Okay, so here our base is equal to 8. So we have base is equal to 8 to the power of y. So y is equal to 0 equals x. So x would equal 1. Okay, so b to the power of x equals y. Convert that to log of base b. So our b is equal to 8. We know that. Of x, we know our x is equal to 1. Is equal to y. Our y is equal to 0. 8 to the power of 0 equals y. Okay, so it's the same thing we did up here, just in reverse. Okay, so let's do another one. 6 to the 1/3 power equals cube root of 6. So in this one, b is equal to 6. to the power of y, so we know y is equal to 1/3, equals x, so we know x is equal to cube root of 6. Okay, now you don't have to write these down, obviously. If you can convert them without it, you can, but if writing it down helps, by all means do that. Okay, so log base b of x equals y. That gives us log base b, log base 6 of x. So x is equal to cube root of 36. Cube root of 6, sorry about that. Equals y. And y is equal to 1/3. Okay, now I want you all to convert that one to logarithmic form. Alright. So I'm assuming you've pressed pause and you've converted this one to logarithmic form. Okay, so we can go here in our base. We see that's equal to 6. B to the power of y, so our y is equal to -2, equals x, so that means x would equal 1/36. Okay, so log base b, so that's log of base 6 of x, so x is equal to 1/36. Equals y, so y is equal to -2. Okay, so that's how you convert from exponential form to logarithmic form and logarithmic form to exponential form. Okay, so now we're actually going to solve logarithmic equations for our x value. Alright, so if you're still writing, feel free to press pause, but we're going to go ahead and move on. Here we go. Alright, move that down a little. Alright, so let's say, for example, we want to solve for x. Okay, so for problem A, we want to solve log base x of 25 equals 2. For problem B, we want to solve log base 3 of x equals -3. And for problem C, we want to solve log of base 1/2 of 1/16 equals x. Kind of clean up that 1 a little bit. There we go. Okay, so you notice in some cases you'll have a parentheses, and others you might not have a parentheses. It's just the way some of them will look. Okay, just to kind of get you familiar with both of them. Alright. So let's look at problem A. But you want to remember, log base b of x equals y is the exact same thing as b to the power of y equals x. Okay, so we're going to use that to solve these. Okay, so we have log base x of 25 equals 2. Okay, so we see here, your x, that's your base. This, just here, that's your x position. And just to let you know, if you wanted to change that to a b, just to make it a little easier, you could, and then just solve for b. that won't change anything. It's just a variable. So if you want to change that to a b to match this, you can. That won't hurt anything. Okay, you see here, that's your y value. So you have your base, your x position, and your y value. Here, well, we may as well change that to y position. That's a little more accurate. We go ahead and we just convert that to our b to the power of y equals x. So your base, we see that's x. Okay? To the power of y, we see that's our 2 here, equals x, or x position, so we see our x is equal to 25. Okay, so we have a logarithmic converted to exponential. So now from here, we just go ahead and solve. Okay. You can use the square root property, or you can subtract 25 from both sides and use the difference of squares. It doesn't matter how you solve it. It's completely up to you. Okay, but what we're going to do, we're going to go ahead and just square root both sides. So the square and the square root here cancel each other out. So you just have x equals, and square root of 25 is plus or minus 5. So we see that x is equal to 5, or x is equal to negative 5. Okay, but remember, if you go back to where we started, just bringing this up, notice your base has to be greater than 0 for both your exponential and logarithmic. Okay, so your base is the positive number. So we see here we can't use that because base b is greater than 0. So this is your only answer. X equals 5. All right. Okay, so let's go ahead and move up to problem B. And go ahead and separate that. Okay, so for problem B, you have log base 3 of x equals negative 3. And remember, we want to convert it to our exponential form. So we have our base, well, our base, our x position, and our y position. Okay, so we just convert this to b to the power of y equals x, which is our base, which is 3, to the power of y, power of negative 3, equals x. Okay, so we go ahead and solve this. 3 to the power of negative 3, that's just 1 over 3 to the power of positive 3. Let me clean that up a little bit. So it's a little bit of a clearer 3. 3 to the power of 3 equals x. Okay. So we know that 3 to the power of 3 is just 3 times 3 times 3, which is 27. Actually, that's bothering me because it's not very clear. Okay, so that's 1 over 3 to the power of 3. There we go. I feel a little bit better about that one. Okay, so that's 1 over the power of 27 is equal to x. Okay, so once you convert it to exponential form, you're set here. It's just remembering your rules of negative exponents. Alright, so let's move on to problem C. Okay, so for problem C, we have log of base 1/2 of 1/16 equals x. Alright, so what I want you to do is I want you to press pause and try to solve this one on your own using the same method we used up here. Alright, so I'm assuming you've already pressed pause and you've worked this one out. Let's go ahead and verify your answer. Okay, so we have log of 1/2. And if you want to put parentheses around the 1/16, you can. You just don't have to. So 1/116 equals x. So just like before, we have our base, we have our x position, and we have our y position. And again, if you wanted to change that to y just to match up with, let me move this down, this up here, you can. Alright, so if we convert that, b to the power of y equals x, our base would be 1/2 to the power of y, that's our y position, equals x, so that's equal to 1/16. Alright. Now, before we can convert that, we have to get our bases to match. So, you want to remember or notice that 1/16 is equal to 1/2 to the 4th power. Okay, so this would actually be converted to 1/2 to the power of x equals 1/2 to the 4th power. Okay, so just like before, as long as our bases match, our exponents would have to be equal. So we have x equals 4. Alright. Alright, so if you're still writing, feel free to press pause, but we're going to move on to our next example. Okay, so what if we want to find the value of x if, let's say for problem A, log base x of 49 equals 2, and for B, log base 4 of 1 equals x. Okay, so I want you to go ahead and press pause and solve both of these. Alright, so assuming you've pressed pause and worked both of these out, we're going to go ahead and verify your answers. Okay, so for problem A, we have log base x of 49 equals 2. Okay, this is our base. This is our x position. Again, if you want to change that to a b, you can. And this is your y position. Okay, so our b to the power of y equals x. We know our base is x to the power of y, so x squared, equals our x position here, which is 49. And again, if you wanted to subtract 49, you could, but we're going to go ahead and just square root both sides. Okay, square root and square cancel each other out. Square root of 49 is positive or negative 7. Okay, so we have x equals 7 or x equals negative 7. Again, we know the base has to be greater than 0. So that would be your answer. Okay, and again, if you wanted to, you could have, instead of having x here to avoid confusion, you could have changed all those to a b. Okay, it doesn't matter, because remember that it's just a variable. So that would have just given you b squared and b, and that would have been b and b, and it would still be the same answer. But I do know sometimes having an x here and then you have an x position, that can get a little confusing, so you can just change to b and plug it right on in. Alright, so let's go ahead and solve for problem B. Okay, so log base 4 of 1. Instead of x, we can just make that equals y. X, you can just make that log base 4 of 1 equals y, just to match up your formula. Okay, so we have our base, our x position, and our y position. Okay, so if we have our b to the power of y equals x, plugging everything in, we have our base to the power of y, so 4 to the power of y equals 1. Okay, now this one, you do have to remember something. And the thing you have to remember is four to the power of 0 equals 1. Okay, anything to the 0 power equals 1. So that 1, you can rewrite that as 4 to the power of y equals 4 to the power of 0. So as long as our bases match, these two have to be equal for this to be true. So we see here that y is equal to 0. Alright, so just a little bit of remembering all of those old properties of exponents and everything else. Alright. So this is just a quick list of some of your properties of exponents. Okay, log base a of 1 equals 0, log base b, whichever one you want to use, or a to the power of 0 equals 1. Log base a of a equals 1, or a to the power of 1 equals a. You don't have to memorize these, it's just something that's handy to know. Okay, so by all means, don't worry about memorizing them. Okay, so a to the power of log base a of x equals x. And the proof of this is right here. So if you have log base b of x equals y, actually we're going to, so if you have b to the power of y equals x, so you have your base to the power of y equals x, so that converts to log of your base of x equals y, which just means that log a of x equals log a of x. Alright, so in other words, all you're doing is you're taking this exponent, where this is your base, that's your y, and that's your x. So b to the power of y equals x. So if you convert that, your base to the power of y equals x. Okay, so basically all this runs true, and you have log base a of x equals x. So a to the power of x equals a to the power of x. Okay. So we're going to go, again, you don't have to memorize these. These are just properties that are handy to know. Okay, so now we're going to start with natural logarithms. Okay. And again, this top part, you don't have to memorize it or anything. This is just an explanation as to where the natural logarithm comes from. Okay. So what if you have the function 1 plus 1 over n, and that entire thing is to the nth power? Okay. So what we're doing here at this table is we're replacing n with values that are getting larger and larger and larger. Okay, so if you plug in, replace n with 1 here, you end up with 2. If you replace n with 2, you end up with 2.25. If you replace n with 4, you end up with 2.4414, and it keeps on going forever and ever. Same thing with 12, you end up with that value. If you plug in 365, you end up with that value. If you replace n with 1,000, you end up with this value. If you replace n with 100,000, you end up with this value. If you replace n with 1,000,000, you end up with this value. Okay, so as n gets bigger and bigger and bigger, 1 plus 1 over n to the nth power gets closer and closer and closer to 2.718 and keeps on going forever and ever and ever. Okay, so that value, as n gets bigger and bigger and bigger, 1 plus 1 over n to the nth power, as n approaches infinity, is equal to a value that we call e. Now in this case, e is not a variable, e is equal to an actual number. And that's 2.7182813, and it keeps on going forever and ever and ever. That's your value of e. Okay, so that numerical value to the power of x is actually called your natural exponential function. Or, well, we can convert that to a natural logarithm. Okay, so remember, you don't have to memorize that. That's just a quick explanation. Okay, now using that with what we're doing so far with logarithms, if you make your base equal to this value of e, then log of base e equals x. We call that the natural log of x. Okay, but it's only defined when x is greater than 0. It's just like any logarithmic function. Okay, so whenever you see natural log of x, that's just a log function with a base of e. That's it. That's why all of this up here, you don't have to worry about remembering or anything. This is the main part of it. All right. Okay. Okay, so if you're still writing this part, feel free to press pause and finish up. But we're going to go ahead and start with our natural log examples. Okay. Now, one thing you will want to note that comes in very, very handy, the value e and natural log will cancel each other out. Okay, so what that means is that e to the power of natural log of x equals x, or natural log of e to the power of x equals x. Okay, so e to the natural log of x, the natural log and the e will cancel out, leaving just the x value. And we have natural log of e to the power of x, the natural log and the e will cancel each other out, just leaving your x. Okay. So let's say, for example, you want to solve natural log of e. Okay. So solving that, natural log of e is the same as saying natural log of e to the first power. Okay. So remember, just from up here, natural log of e to the power of whatever, the natural log and the e will cancel each other out. So natural log of e is just equal to 1. And again, you can plug that into any calculator and it'll give you just 1. Okay, so let's say, for example, we wanted to solve natural log of 1 over e squared. Okay, same thing here. Natural log of 1 over e squared, that's the exact same as saying natural log of e to the negative 2 power, because 1 over e squared is just equal to e to the negative 2 power. Okay, so again, noticing up here, your natural log and your e cancels each other out, so you're just left with negative 2. Okay, so that one's pretty straightforward. Those aren't too many steps involved in solving those. Okay, so let's go ahead and move on to our next example. All right, so we're going to see when your problem appears a little bit different. Okay, now when your logarithm does not have a base, there we go. Okay, then we assume that your base is equal to 10. Okay, this is called a common logarithm. Called a common logarithm. Okay, so in other words, you have log, if you just have log of x, that's the same as saying log base 10 of x. Same thing. It's just whenever you have no base given, your base is 10. Alright, so let's say, for example, we want to evaluate for problem A log of 1000. Say for problem B log of 1 over 100. And let's say for problem C you have log of 10. Okay. Now at first glance it'll seem like that's not much to go on, but that's actually everything we need to solve each one. Okay, so for problem A, if you have log of 1000, we're going to rewrite it. Remember, when there's no base, our base is 10. So we have log base 10 of 1000. There's nothing here. There's no equal sign. We can just make that equal y. Okay. So whenever there's no equal, just make it equal an unknown variable, because that's what you're solving for. Okay. So remember, you want to convert that b to the power of y equals x. So this is your base. So you have a base of 10 to the power of y equals 1000. Okay, now we can also remember that 10 to the third power is equal to 1000. So we have 10 to the power of y is equal to 10 to the third power. Our bases are the same, so these two would have to be equal. So we see here that y is equal to 3. Okay, let's go ahead and do our next example, or example B. So you have log of 1 over 100. We're going to rewrite that as log of base 10 of 1 over 100 equals y. Okay, and again, our b to the power of x, b to the power of y equals x. B to the power of y equals x. So that's 10 to the power of y equals 1 over 100. Okay, so we know here that 1 over 100 is equal to 1 over 10 squared. Or 1 over 10 squared, you can make that 10 to the negative 2 power. Okay, so we have 10 to the power of y equals 10 to the negative 2 power. Again, your bases are the same. That means these two would have to be equal. So y is equal to negative 2. Alright, so let's go ahead and solve problem C. Oh, running out of space here. Still got plenty of room. So log of 10, and we can just rewrite that as log base 10. Since we don't have a base, we know it's 10 of 10 is equal to y. Okay, so once we convert it, 10 to the power of y is equal to 10. 10 to the power of y is equal to 10. And we also know that 10 is just equal to 10 to the first power. So we have 10 to the power of y equals 10 to the first power. So once we know our bases are the same, our y is equal to 1. Okay? Alright, so if you're still writing, feel free to press pause, but we're going to go ahead and do a few more examples. Okay, so what if we wanted to evaluate, let's say for problem A, log of negative 10, and let's say for problem B, you have log of 1. Okay, so let's do our problem A. We have log of negative 10. We're going to rewrite it. There's no base, so we know that base is 10. Log base 10 of negative 10 equals y. Okay, now converting that, 10 to the power of y equals negative 10. Okay, now if you notice here, there's no value of y that you can make to make 10 or negative 10 equals 10 to the positive of some value. If you make y equals 0, 10 to the power of 0 is 1, so 1 isn't equal to negative 10. If you make y a negative number, let's say negative 2, that'll just make it 1 over 10 squared, which isn't equal to negative 10. If you make it a positive number, let's say if you make it a positive 3, that's just 10 to the third power, which is 1,000, which isn't equal to negative 10. So really, there's no value of the exponent y that will make 10 to the power of y equals negative 10. That's why your x always has to be a positive value. You cannot have a negative value in your x position. Okay, so in this case, log of negative 10 is what you call undefined. Okay, that's why we have that. Let me go back a few pages. Let's see if I can find that list of rules here. Here we go. That's why we had x is positive. Okay. Alright, so let's go to our B example. Say log of 1. Okay, we can convert that to log base 10 of 1 equals y. Remember, that's 10 to the power of y equals 1. Okay. And if you remember, anything raised to the power of 0 can equal 1. So this you can rewrite as 10 to the power of y equals 10 to the power of 0. And again, your bases are the same. So that just means that your y is equal to 0. Alright. So, hopefully this made sense, and I will see you on the next video.